Hi everyone, Rao sir here. Welcome to Rao's chemistry classes. This video I am going to give wonderful trick, that is how to write electronic configuration for F block elements, particularly lanthanoids and actinoids. So listen very properly. Why? Because most of the students, they can easily write S block, V block, D block elements electronic configuration, but when it comes to F block elements, they feel somewhat difficulty. So that's the reason I am going to give my personal trick. You have to listen very carefully. Yeah, just look at the board. F block elements. So what is the definition of F block elements? The last electron enters into F subcell. The last electron enters into F subcell are called F block elements. Otherwise we can say like that. The differentiating electron enters into F subcell. The differentiating electron enters into F subcell are called F block elements. Yeah. So here F block elements contain two series. So total F block contains two series. Number 1 4F series, number 2 5F series. So 4F series is nothing but lanthanoids, 5F series is nothing but actinoids. Just look at the board. So F block elements, two parts, lanthanoids and actinoids. Lanthanoids and actinoids. So lanthanoids belongs to 4F series. It is belongs to 4F series. Actinoids, it is belongs to 5F series. So first we need to discuss what is the general electronic configuration of F block elements. What is the general electronic configuration of F block elements? The general electronic configuration of F block elements is N-2 F1 to 14 N-1 D0 to 1 NS2. NS2. But what about lanthanoids? What is the general electronic configuration for lanthanoids? Simple logic. Simple logic. So 4F, you have to start with 4F. N-2 is nothing but 4F. N-1 is nothing but 5D. N is nothing but 6. Yeah. So then it becomes like this. 4F 1 to 14, 5D 0 to 1, 6S2. Same logic. It starts with 5F. 5F 1 to 14, 6D 0 to 1, 7S2. So this is the general electronic configuration for this one, and this is the general electronic configuration for this one. Next important point, lanthanoids contain how many elements and actinoids contain how many elements? Already I told you, total F block contain 28 elements. Out of 28, lanthanoids 14, actinoids 14. So here one important point, after lanthanum, lanthanoids started. After actinium, actinoids started. Yeah. So lanthanum, after lanthanum it started. Cerium 2, lutetium. So here lanthanum atomic number 57, cerium atomic number 58. So 58 to 71. 58 to 71 means 14 elements. This is the range. This is the lanthanoids range. Next, when comes to actinoids, after actinium it started. So actinium, next thorium, thorium to lawrencium. So actinium atomic number 89, thorium atomic number 90, 90 to 103. So 90 to 103 means 14 elements. Yeah. So you don't consider this one and this one. This one is D block element, this one also D block element. So 90 to 103, 14 elements, and 58 to 71, 14 elements. Is it clear? Yeah. Okay students. Next. So how to write electronic configuration for lanthanoids? This is the trick. Just look at the board. First. So lanthanoids general electronic configuration 4F 1 to 14, 5D 0 to 1, 6S2. So these are the lanthanoids. These are the lanthanoids. After lanthanum, lanthanoids started. So lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, godolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. So these are the elements. Atomic number 58 to 71. So first, how to write electronic configuration? Simple logic. Basic units 4F, 5D, 6S. You have to write like that. 4F, 5D, 6S. Same pattern. No change. Is it clear? Yeah. Next, what should we do? So, total 14 electrons are there. That indication total 14 elements. So 14 elements means 14 electrons. 1, 2, 3, 4 like that up to 14. Next, what is the trick? Don't take 2 and 8. This is 2 and this is 8. Don't take 2 and 8. So we have to cancel 2 and 8. Next, don't change 7 and 14. 7 means half filled, 14 means full filled. Total f orbital capacity 14 electrons. That indication 14 electrons means completely filled. 7 electrons means half filled. These two are stable. That's the reason don't change. Just look at the board. Here 1 means you have to take 1. Here 2 already cancelled out. That indication you have to take next number. 2 next number 3. Same logic. 4, 5, 6, 7. Here 7, 7. Here 8 next number. 9, 10, 11, 12, 13, 14. Here 14, 14. This is the trick. This is the trick, my dear students. Once again, you have to take 14 electrons. Next, don't take 2 and 8. And next, don't change 7 and 14. So here 7, 7, 14, 14. Next, 1, 1. 2 next number 3. Same logic. Next 8 next number 9. Next same ascending order. Yeah. Lanthanum. Once again, dear students, lanthanum, it is not a F block element. It is a D block element. That indication here F orbital not having any electrons. That's the reason here 4F0 and 5D1 and 6S2. And one more important point, lanthanum atomic number 57. That indication lanthanum contains 57 electrons. So let me cross check. So here you need to write xenon every case. Xenon every case. Xenon is nothing but a noble gas element. This is the shortcut representation. Initially you need to take xenon. Yeah, xenon atomic number 54. Everybody knows. 54 plus 1, 55. 55 plus 2, 57. Is it correct or wrong? 100% is correct. Yeah. Next. So here lanthanoids are started. This is the first lanthanoid. Yeah. 4F1. 1 means 1. Next. 3. Next. 4. Next. 5. Next. 6. Next. 7. Next. 7. Next. 9. Next. 10. Next. 11. Next. 12. Next. 13. Next. 14. Next. 14. Yeah. These are the F electrons. You have to write like that. Next. What about S? There is no change in S. Why? Because 6S2. That indication each and every element ending 6S2, that is fixed. So 6S2, 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 2 like that. Yeah. So what next? 5D 0 to 1. 0 to 1. Simple logic, my dear students. Very simple logic. Very simple logic. Here cerium atomic number 58. So 58 means xenon already 54 electrons. 54 plus 1, 55. 55 plus 2, 57. That indication here you need to write 1 electron. Then only it becomes 58. That is the logic. Next, what about this one 59? Xenon already 54. 54 plus 3, 57. 57 plus 2, 57 plus 2, 59. That indication no need to write electron here. So 0, 0. What about this one? Same logic. 0, 0, 0. Here, what about this one? So europium 63, xenon 54. 54 plus 7, 63. 63 plus 2, 65. So you need to take, once again dear students, xenon atomic number 54. That means 54 electrons. 54 plus 7, 61. 61 plus 2, 63. So no need to write electron here. So here you need to write 1 electron. Then terbium 65, xenon 54. 54 plus 9, 63. 63 plus 2, 65. So no need to write electrons here. So 0, 0, 0, 0, 0, 0, here 1. So ultimately here last one gets D1 and Godolinium gets D1 and starting two elements gets D1, whereas remaining D0 only. This is the technique. Just look at the board. Just look at the board. Okay students, in examination you will get questions like this. First one, what is the outer electronic configuration of Godolinium? Yeah. So first you have to take xenon. Next, as usual, 4F, 5D, 6S. So here Godolinium 64. 64 means this one. 4F7, 5D1, 6S2. 4F7, 5D1, 6S2. Once you have to cross check it, xenon 54. 54 plus 7, 61. 61 plus 1, 62. 62 plus 2, 64. Is it clear? Yeah. So this is the outer electronic configuration. Here, cerium atomic number 58. So electronic configuration is xenon 4F1, 5D1, 6S2. This is for cerium, but we want cerium plus 3. Plus 3 means loss of 3 electrons. Here you need to remove 2 electrons and here you need to remove 1 electron. Then it becomes like this. Xenon 4F1. That's it. Xenon 4F1. This is for cerium plus 3. Is it clear? Yeah. Next, actinoids. How to write electronic configuration for actinoids? So actinoids, this is the general electronic configuration. 5F1 to 14, 6D 0 to 1, 7S2. After actinium, actinoid should be started. So this is actinium, thorium, protoactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendeleum, lowolium, lawrencium. So these are the actinoids. So 89, 90 to 103. So first what should you do? First you have to write like that, basic key points, basic units, 5F6D 7S, 5F6D 7S up to Lawrencium. You have to write like that. Next, what is the trick? This is the trick. Don't consider 6 and 8. At the same time, don't change 7 and 14. Don't change 7 and 14. Next, don't take 6 and 8. Next, as usual, 1, 2, 3, 4, 5. 6 next number, 7. 8 next number, 9. As usual, next number, 10, 11, 12, 13, 14. You have to write like that. Yeah. So here, this is actinium. It is not a F block element. It is a D block element. That's the reason no F electrons. So you have to write 0. What about this one, thorium? 1 means 1, 2 means 2, 3 means 3, 4 means 4, 5 means 5. Same logic. Next 9. Next, this is the sequence. 10, 11, 12, 13, 14, last one 14. Is it clear? Next, don't change this one, 7s2, every case 7s2 only. 2, 2, 2. Is it clear? Next, so if you know f orbital electrons and s orbital electrons, then automatically you can write d orbital. So initially you have to write radon. Radon is nothing but noble gas element, atomic number 86. So 86 plus 2, 88. So here 1 electron is there. Yeah, this is d block element. Next, thorium. Thorium, here radon. Radon means 86. Radon means 86. So here F 1 electron, next S 2 electrons. So 86 plus 3, 89, but here atomic number 90, that means you have to write 1 here. You have, okay students, actinoids, like that you have to write. Okay, so first, what is the general electron configuration? 5f1 to 14, 6 to 0 to 1, 7s2. So next you have to take a basic unit 5f6d7s, 5f6d7s for every element. Before that you need to write radon. Clear? Next, what is the trick? Don't take 6 and 8. Don't take 6 and 8. Next, don't change 7 and 14. Yeah, same procedure like lanthanoids. Thanks for watching this video. Each and every student, please subscribe my channel. To get further notifications, click the bell button. Bye for now. See you again.